Good evening, class. Today's lecture will be about the Pythagorean Theorem and trigonometric identities. Please like, comment, and subscribe. Please donate on the Cash App with the $ up front, MLBFsn. Please text 559-744-3169 for math help. Please text 559-744-3169 for math help. So here's the Pythagorean theorem, and that states a squared plus b squared is equal to c squared, where a and b are the legs. So a and b are considered the legs of the triangle. So let's draw a triangle. And C is considered the hypotenuse. And C is right there where the diagonal of the triangle is. So let's solve for A first. So a squared plus b squared is equal to c squared. So we have to subtract b squared to both sides. So a squared is equal to c squared minus b squared. So then we take the square root to both sides. So the square root of a squared is equal to the square root of c squared minus b squared, breaks down to a is equal to the square root of c squared minus b squared. Now let's solve for b. So we start with the Pythagorean theorem again. A squared plus b squared is equal to c squared. So we subtract a squared to both sides. Whatever you do to one side of an equation, you have to do to the other. This is according to PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, or please excuse my dear Aunt Sally. And so we subtract a squared to both sides, and we're left with b squared is equal to c squared minus a squared. And then we take the square root to both sides. And this is a reminder, when we're taking the square root to both sides in trigonometry and geometry, we only want to deal with the plus case. So normally when you take the square root to both sides, you get a plus or minus case, but in trigonometry and geometry, we just want the positive case. So square root of b squared is equal to square root of c squared minus a squared. So that breaks down to b is equal to the square root of c squared minus a squared. So let's let that marinate, and then we'll solve for c. So a squared plus b squared is equal to c squared. So we have to start with the Pythagorean theorem again. So in this case, we just take the square root to both sides. So the square root of a squared plus b squared is equal to the square root of c squared. So that breaks down to c is equal to the square root of a squared plus b squared. So now let's take a look at the special triangles. So we have a 45 degree, 45 degree, 90 degree triangle where the sides are A is equal to 1, B is equal to 1, and C as the hypotenuse is equal to the square root of 2. We want to prove the sides. So let's prove the sides through the Pythagorean theorem. So a squared plus b squared is equal to c squared. So we know a is 1, so 1 squared, and b is 1. So 1 squared is equal to c squared. So 1 squared is 1, and so 1 plus 1 is equal to c squared, and then we take the square root of 1 plus 1 and the square root of c squared, and that breaks down to c is equal to the square root of 1 plus 1, which breaks down to 2. So that proves that c is equal to square root of 2. So that has been proved. So now let's prove the 30, 60, 90 triangle. Let's let that marinate there for a little bit. So let's prove the 30, 60, 90 triangle. So the 30 degree, 60 degree, and 90 degree triangle with side measurements of a is equal to square root of 3, b is equal to 1, and c is equal to 2. For this one, keep in mind that we need the Pythagorean theorem, so let's prove this by the Pythagorean theorem. So a squared plus b squared is equal to c squared. So a is square root of 3, and we're going to square that, and b is 1, and we're going to square that as well. It's equal to c squared. So square root of 3 squared plus 1 squared is equal to c squared. So let's rewrite that. Square root of 3 squared plus 1 squared is equal to c squared. So since the exponent is 2 for the square root of 3, so we want to write that twice. So square root of 3 times square root of 3 plus 1 squared is 1 is equal to c squared. And we need to know the formula of the square root of AB is equal to the square root of A times the square root of B. Right now, square root of 3 times square root of 3 is in the form of square root of A times square root of B, and we want to put it in the form of square root of A, B. Since they're the same root, we could bring them together. So square root of 3 times 3 and plus 1 is equal to c squared. So the square root of 3 times 3 is the square root of 9 plus 1 is equal to c squared. Square root of 9 is 3. So 3 plus 1 is equal to c squared. 4 is equal to c squared. And take the square root to both sides. And c is equal to 2. So this has been proved. So we found out through the math here that the hypotenuse of C is equal to 2 is true. Now let's get to a problem here. So let's say a triangle has C is equal to 5 and B is equal to 1, and we don't know what A is. So we have to use the Pythagorean theorem to figure this out. So the Pythagorean theorem is a squared plus b squared is equal to c squared. So we just fill in here. We know c is 5, so 5 squared. And we know b is 1, so 1 squared. So a squared plus 1 squared is equal to 5 squared. So a squared plus 1 squared is 1, and 5 squared is 25. So a squared plus 1 is equal to 25. And then we subtract 1 to both sides. So a squared is equal to 24. And then we take the square root to both sides. And then to break down to a is equal to the square root of 24. And this is going to be an irrational root. So we need to know the formula. Square root of AB is equal to the square root of A times the square root of B. And we know 24 is equivalent to 4 times 6. We want to look for a perfect root within an irrational root. So we want to look for a perfect root within an irrational root. So 4 times 6 is 24. So the square root of 4 times 6, and that's what that is going to be so far. So a is equivalent to square root of 4 times 6. And then a is equal to the square root of 4 times the square root of 6. Square root of 4 happens to be a perfect root within an irrational root. So a is going to break down to 2 square root of 6 because the square root of 4 is 2. And then we will discuss the trigonometric identities in the next video. So, if you need math help, please text 559-744-3169 for services. Please donate on the Cash App. With the $ up front, MLBFsn. Thank you so much, and let's learn math together. And since we found out what A is, and then we just substitute it back here. Thank you so much, and let's learn math together.